Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. Welcome back to my Exploring Lyra series. Since the first test episode was so well received, I figured we can give this a few more tries and see what else we can learn from this project. This time I figured we could try and see if we can learn something from the procedural meshes, because from the demonstration I was shown, or everyone was shown, it looked like they were pretty cool things, and I would like to learn a little bit more about how they work. So, if we're currently in the start lobby screen again, like we always, and load up in currently. And if we mark the all folder and click on the filter button here and choose level, we can see what levels we have available. And let's see if we can find a level where we have some of these meshes available. So let's start from left to right, I guess. Okay, this was a very empty level. I'm going to assume that it has to do with world partition. So let's load in these cells and see what happens. Excellent, this looks very promising. Okay, so we have one of the playable levels here. Let's see if we can find a static mesh. He clicked on a wall, I remember. Was it generated tube advanced, edit baked mesh actor? Okay. Tool advanced window. Tool stairs. He right-clicked on them and he could go swap to generated mesh. I think this might be one of those. Let's create a copy from this one by alt dragging it out. And let's see if we can change it to a generated mesh. Okay, that seems to work. We seem to have gotten a couple of 3D widgets here which can change how this one looks. So we have a mirror location. Okay, so it has a duplication of itself, it seems. And custom cutter, I don't see that doing much of anything. And then we have an opening which changes how it is. Okay, so that's interesting. So let's see here. Okay, first thing we notice is that if we check in the world outliner here, we can see that the name has changed. If we change it back, yeah, it goes from a static mesh actor to being a blueprint. Oops, did I click the wrong one? No, I didn't. Excellent. Okay, so now we see that it's a sort of blueprint here called B-Tool Advanced Window. And here we have something in an event graph describing a bunch of steps to accomplish, I'm assuming, what is the procedural generation. What's this? Advanced window tool with lots of options can be used to generate walls, doors, floors, ceilings, etc. It's a complex geo tool. Understanding basic ones first is recommended. Okay. Let's see if we can do that then. So let's see where this one is located by browsing to it. Okay, so we have a bunch of tool named blueprints here, which are in the tools folder. So I'm assuming all of these are of the procedural generation types. And based on the names, I would say that this one is possibly the most basic one. It's a window like the one we have, but it's not called advanced. Let's open that one up and see what that's like. Okay. Really basic wall with window. Wasn't used after the advanced version was created. Okay, well, this seems to be what they're referring to then as learning from the basic one first. So, what can we learn from this one? We can see that this one has a parent class of generated dynamic mesh actor, and that one is this one is the lowest level we can reach in blueprints. Is it the same for the other one? No. This one has a baked generated mesh actor. Let's see what that one looks like. Okay, so the baked generated mesh actor has a common parent with the basic window door one. They have the same parents. So we have an abstraction of functionality here in the case of a parent when it comes to the advanced one. So let's just see what this is all about. Clean the generated trees. So this seems to be... It seems like we are getting some kind of list of triangles, probably from altering the mesh. And then we're adding certain things within a threshold, it seems. Because we have a tolerance here, and we're adding some degenerated trees to a list. Once we're done with this, we go through here and we seem to be deleting superfluous triangles. So I'm going to assume that this is just some kind of cleanup. And we do have some other things here. Let's go check the event graph. We go to begin play. It's empty. We have a function or an event that can be used in children. We have a event on rebuild generated mesh. Okay, so not a whole lot being done here. And we have an apply materials, which is blank. And we have some variables here as well. Okay, let's compare that quickly with the window and see. Okay, so the window is clearly much simpler in comparison. So this one gives some functionality, although not a whole lot, it looks like. And it seems like this might be an important event. Let's go check this. So now we're in the advanced tool again. So we're checking clearing materials. Okay. Event on rebuild. Was that the same one? Yes. Okay. So everything here is connected to this event. So it seems. Okay. So this seems to be a core part of the generated meshes. And if we go to our simple window, we have the same here as well. Okay. This event will be fired to notify the blueprint that the generated mesh should be rebuilt. Generated dynamic mesh actor subclasses should rebuild their meshes on this event instead of doing it so directly from this construction script. Okay, so it seems like normally in Unreal Engine 4 we would have, if we wanted to have things update immediately in the editor, we would put things in the construction script to have it reflected immediately. It seems like they have hooked on that kind of functionality in this event when it comes to the procedure of meshes, so that we are allowed to do things like changing things when it's updating. And we see that it's rebuilding navigation that's related to the nav mesh, I'm gonna assume. Okay. So let's look at the simple one and see what we can figure out here. So we have a dynamic mesh component apparently. We have that one over here. It comes from our parent class. I'm assuming. Yeah. So in this we get the dynamic mesh that is in the component. We reset it. We have wall plus window. Okay, so we're appending a box which has some coordinates for wall size. And then we're allocating a compute mesh. Request a compute mesh from the pool which will return a previously allocated mesh or return a new one. Alright, so this sounds like we're getting a temporary mesh to play around with, if I understand that correctly. And then we're sending that one into another append box, which is making use of the same parameters, it seems, for location and dimensions. And then we're applying a mesh boolean. Okay, and we're having a subtract operation here. So this sounds sort of like how you created what's it called, BSPs in Unreal Engine 4, sort of. It seems like we're trying to create one box and subtract another box from that box. And let's try and drag out this window into the world and see what it looks like. Okay, so we have two widgets available. We have a window size and a window position. Window size over there and window position over there. So let's find references for window position. We have it in one place, which is here. Okay, is this going to be the only window size also then? Find references. It seems like it does. Okay, so these are the only occurrences for our 3D widgets. So if we click on them, you can see 3D widgets are enabled for these. So that's why we can see them. And it seems like this one does not have one then. So if we were to make this one instance editable and show, we did not get, oh wait, there we are. We have another widget over here now. Okay, so now we can control, I'm going to assume all axes. So it seems, okay. So we can come to the conclusion here that we're doing boxes dynamically, and when we have widgets available on them, we can just easily manipulate them in the editor instead of having just hard-coded values, which you can of course also expose, but it makes it a little bit more difficult to let's see here, if we go to here, wall size, if we were to change wall size here to 500, that's not as easily workable as working with the widget in this case. So that all makes sense. And this allocate here, what happens to that when it appends and it subtracts, and then we create another one. Okay, so it's commented as, this one says wall and window, and this one says window border. Okay, so we're creating another box, presumably with all the same parameters. Yeah, looks like it. And we enable material IDs, okay, and we remap the material IDs. And then we apply a mesh boolean with a union this time. And we're doing it with the result after we had subtracted the second one. So it seems like when you're doing a Boolean operation, you're having an origin and an effector essentially. So what we're getting out here, I'm going to assume is the result. So we're using the result from that operation as our target here to then do a union, which will be the window border, which I'm going to assume is this slightly grayer area over here going around the window then. All right. Are we done after that, or are we doing more things? We're appending another box to subtract. Okay, it's to give the border of the window a slightly more indented look, I'm assuming. And then we clean up the generate trees. This was the one we... Yeah, so this is the function that we ended up in earlier. So this is probably just to... I'm going to assume that as you affect the geometry, that you're building and rebuilding and changing all the faces on the geometry. And let's actually, we can probably see that, right? So if we go to wireframe, okay, that was not super clear. Let's see if we can make this work anyway. So we're changing, we're not getting more or fewer triangles as far as I can see. But that might depend on what kind of operations you're doing as well, I suppose. Since these are pretty simple, I'm assuming they're not changing. So this one might not be necessary unless you do like pretty complex versions of this, I'm assuming. Moving on, and then we apply materials. We get the dynamic mesh component, and we have some hard-coded materials. Okay. And when we release all compute meshes. Okay, so I'm going to assume that this is clean up to make sure that all of these allocated meshes are garbage collected after they have been altered with. So that's probably good to always have with you. It does look like we're hard coding materials, so it doesn't look like we can actually change materials on this one. So let's see, we have a white and a gray material on this one, it seems. Let's pick something. What kind of materials do we have in this? Let's just pick this one and see what happens. Okay, nothing seems to be happening. How does it react to breakpoints, I wonder? We can't debug since we're in editing mode, but if we're changing a material... No, nothing. Wait. Hit breakpoint. Okay, so we can determine that the code is running at least. It noticed the breakpoint. It did take a while. Is it... Seems like this is being called not super fast. Okay, let's remove that breakpoint because that will be spammy pretty soon. Okay. But this looks pretty straightforward at least. It doesn't seem overly complex, and that's probably good because it's a basic version of this. Let's try to create our own one, I suppose. So we have a generic dynamic mesh actor. So let's create a folder called test. And let's create a new blueprint. Let's call it... right, what was the name? Memory is not what it's supposed to be. Generated dynamic. Generated dynamic mesh actor. Okay, we'll call this just test. And let's drag that out into the world. So currently we have nothing. If we open up this, we have in the viewport nothing, construction script, event graph. Okay, so everything is blank here. Let's get rid of these events and let's see what event did we have here. It was the rebuild generate mesh. So rebuild generate mesh, which is taking a target mesh input. But we're getting ours from the component. Let's start off simple. Let's do this. Let's copy this append box here because this is where I'm interested in what's going to happen. Let's right click on this and create a variable and hook it up. And let's see, let's compile this and give this some standard value. So 100 times 100 times 100 means it's a 1 cubic meter cube. And let's get the dynamic mesh from this and hook it up like so, and then we plug it in here. Let's see, what else do we have here? We have a transform, primitive options. Okay, well that's all fine. Let's see what happens. Okay, so we immediately have a box now that's being driven by our parameters here then. So if we make this a widget immediately, we should be able to manipulate this one at once. There is our widget. Yeah. Okay, so that's straightforward. In addition to that, we have this. Is there a difference? What happens if we do this? Seems to work fine. Is this the same? It would make sense that this is the mesh that we're getting in when we're manipulating it. Maybe there is a difference here. It's not completely clear. Let's leave it like this for now. Let's see what we can do with this. So, also in the window we had a reset. I didn't use that one. What does that one do? It clears the internal mesh to an empty mesh. This does not allocate a new mesh to an existing. Okay, this one might be necessary, but it doesn't seem to be hindering us in using this. So that might be something good to keep track of at least. Let's see if we can create a window. Let's just copy this whole part about the appending boxes and making a subtraction. So if we do this, I'm expecting us to... The target mesh here would be the new box that we're having. So we want to allocate one of those temporary ones probably. Right, this one, allocate compute mesh. Let's do that. Over here. So the result from this is what we want to use to create our second box now. And when it comes to transforms, we can give it the same values here as the other one, I guess. We can always change this. Actually, let's not use the same variable. Let's create a new variable. And duplicate, let's call this is going to be a window, so window location. And we also have dimensions. So let's create a third one and call it window size, I guess. And we'll drag those out. Let's see, now they're all going to be defaulted to 1 meter each. Just collapse this to a pin. And can we do the same here? We cannot. Okay, we'll split this one instead. Where did it go? Come on. Split struct. There we go. Okay, so we're doing like that. Since this was duplicated from our previous one, we should now have 3 different... I thought... Yeah, there we go. So we have a window, they're placed in each other. So windows, I named that wrong, but let's disregard that. And then we have a window location and a window size now, but nothing seems to be happening, and it's saying that target mesh is null. It's good that we're getting debug information at least. So it's saying, I'm gonna assume that this one is blank then, so this should be whatever we're using as our source, which should be this one. Let's see if that works better. Did I get an error? No, it looks fine. Let's see here. So this mesh and window size. So that's the size. Not sure which. Also, I need to make sure that I have as subtract. Yes, I do. Good. Okay, so this one is 1 meter. That one is 1 meter. Or actually, not 1 meter. That is probably the location. So that one we probably want to set to 0, I think. This will probably be a local positioning. So now it's window location down here. We have some artifacting going on there. I'm going to assume it has to do with the size. Okay, so the size... Now as we alter the size, we can see what impact it has on the other mesh. So now we're creating a hollowness in our mesh. Okay, so that's cool. That's pretty simple and straightforward, I would say. So what else did we have here? We have... So there were different Boolean operations, so that's all good and fine. It should be the same as we have done so far, and just playing around with different versions. We seem to have union, intersection, subtract. That makes sense. So union meaning using all the space that's allocated between the two different meshes, intersection being the difference in between them, and subtract just removing one from another. That's straightforward Boolean operations, I believe. We also had the ability to do materials, and it was done in the end here. Applying materials. We mentioned materials some here. So we enable materials on a target mesh, and then we remap it, and then we use the result of that change as a... Okay. So this should mean then we can take this configure and go to our test. Let's put it last somewhere and hook it up. Let's actually make this into parameters also, or variables that we can make use of. 0 and 1 will do fine for now. Okay, so then we need to enable material IDs and remap material IDs. So this should mean then that if we put them in between here, we should get a sending in the result of the box that we used, which is enabling the materials on it and remapping them. The result from that we can use as our tool mesh, and they're remapping 0 and 1. So this should hopefully mean then that our first material is going to be on the mesh and the second material as what we're subtracting, maybe? Is that how it works? Let's see. Let's compile and save and see what's this is like. So okay, so it seems like so far no change. Maybe we need another material here. Also, what materials do we have? I named them really poorly. Did I even expose them? I didn't expose them. Okay, so we'll expose them. So now we have them over here. So they have the same materials as over here. Let's change one of these materials to something else. Something very different, I guess. Pink will do fine. Okay, so it seems like the first material has been placed on the mesh, and the intersection of the Boolean expression has used the second one. All right. Seems straightforward enough. I guess this is just a matter of playing around with it to get what you want to do. Let's see now with this newfound knowledge if we can see what the advanced one does. So it started off clearing materials, and then it's setting its dynamic mesh from the input. That's sort of like how we used it, right? Yes. Okay, so it could be that this is... you could do it either way here, I'm not entirely sure, but it seems like they are using it that way as well. And then they're having some enumerator to decide if a square or a round wall corner will exist, and then it's... Okay, it's just appending again, but using different types of geometry, it seems. So we have round rectangles and boxes, so it's the same thing, just different nodes. This one is a little bit new. This one extrudes. Okay, so we're having a rectangle shape, meaning a 2D shape, and then we're extruding it outwards with a certain thickness, in this case 10 centimeters. And then we're going to a bevel. Okay, so we have some options also to make our corners slightly smoother. And here we have a bunch of what looks to be macros. Yes, so MC for macros. These look like... Okay. I can understand why this is a little bit more advanced than the other one. We have a lot of code in these ones, I'm assuming for flexibility. Alright, so this one will take a little bit longer to dissect, but hopefully with what we have found now we can actually more easily move forward and see what the advanced one does, essentially. So yeah, I hope this, which proved to be very surface scratching exploration into procedural meshes, was informative. And I'm assuming also that this, let's make a quick test actually. Let's open up a new Unreal 5 project. Okay, here we are inside of a third-person template with starter content. Other than that, it's completely blank and new. In here we want to enable plugins, and the plugins seem to be geometry. Geometry script. So geometry provides editing meshes. This one seems to be the one that we're after. So let's use this one, even though it's experimental, and let's restart and see what it looks like. Okay, we're restarted. Let's see if we can quickly just create a blueprint here and see if we can just make use of these procedural meshes here now. So we'll make a actor, or call it BP. No, that's not what I want. It needs to be of the correct type, of course. What was it called? It was dynamic and generated something. Generated dynamic mesh actor. Very advanced name. BP tests. Let's open this up and let's hook it up here. Let's go to the other project and just, since we've already played around with it in the other project, let's just see if we can get exactly everything that we created before. So this is the information we want. And we'll just paste it here. Yes, we need to make a variable for wall size, one for window size. And let's make sure that they're instance editable, and widgets 100, 100, 100, and this one as well. That's not what I wanted to do. Position 0 here is fine. And it's also complaining about our material IDs, of course. Makes sense. Like so. Everything seems to be on the up and up. It feels like we need to make sure that these are instance editable and widget enabled as well, so we can easily manipulate it. Like so. Okay, let's see if it works. Right, so here we have our box. And window size, I'm assuming. So there we have the window size and how it's affecting it, and we have the window location where we can drag it around. So everything seems to be working fine, so it's pretty easy to bring it into any other project and make use of it as you need. So that's pretty cool. Anyway, I hope that this episode proved to at least give you some educational value into procedural meshes. Take care. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.